Hi everybody, Steven here. If you want to learn how to do packet captures inside NSX/NSX-T, stick around. That's what we're going to cover. Got a bit of a lecture and a demo for that. So see you in a bit. Thanks for sticking around, everyone. Let's jump right into it. So let's talk about packet capture. I got a couple little slides here to go through. So this was actually a request from one of the subscribers out there. They wanted to learn about this, so let's go through it. We also need to know some of the basics. So first of all, there's a couple of tools available for us. These are just some of them, right? First of all, there's this live traffic analysis. This is a GUI based packet capturing tool. I can't remember when that came out. It might have been 3.2. Don't quote me. I can't remember. Doesn't really matter. So we'll take a quick look at that. That's a nice little tool. It doesn't really do everything, to be honest with you. Then there's the pkt cap-uw command. This has been around for a very long time. There's also the TCP dump-uw that can also do packet captures. This is available on your ESXi host command line. If you know how to do packet captures in vSphere, boom, same thing here, okay, folks? So this is specific to your ESXi host. Now, with NSX, when you prepare a host as a transport node, so your ESXi host, for example, or an edge or whatever, there is the start capture command. So this is available from the NSX command line interface, so the NSX CLI. So you need to execute the NSX CLI command first, then you have access to the start capture. This is actually a fairly easy command to use. It could actually display the captures live, or you could save it to a file. By the way, the same thing with the pkt cap command. The pack cap command -uw can display it live, or it could also save it to a file, like a pcap file, where you could use something like Wireshark afterwards if you want to, right? You could also use the traffic analysis to also save your files to a pcap file for Wireshark to view it if you want. The cool thing about this start capture command, it's available on all your transport nodes. So I'm going to say this. So if you had a KVM host, you could actually use the start capture command. Now, again, we all know KVM transport nodes are no longer supported in 4.x. So I wanted to get that out there before people start freaking out. But prior to version 4, this start capture command was kind of cool because you could use it on your host or your KVM, but it also works on your NSX edges. And it also works on your NSX manager nodes. So if you actually have access to your NSX manager, or one of the nodes, you can actually use the start capture command or the start capture node command and start capturing packets from the NSX manager. So technically you don't really need to go on to the ESXi host, but I'm going to demo it from the host. Now, before we do this, for those of you that are network savvy and you already know about capturing packet captures and stuff like that, you're quite familiar with like your CCNAs or CCNPs or whatever, you'll probably want to skip this. This is what I refer to just being back to the basics, right? So in my little diagram I have here, and this is important because capturing packets is one thing, but understanding what's going on underneath the covers is another, and you need to kind of know this. So let's just, in this example, I've got a couple of PCs. I got PC A and PC B, right? So there's a couple of computers there. Looks like this computer A is on the 172.16.10 network, and there's its address, 172.16.10.11, and there's its MAC address, AAAAAA. On the far end, I've got another computer, computer B, and it actually has an IP address of 172.16.30.11. So it's on the 172.16.30 network, which is, again, over here. And it has a MAC address of FFFFFF. Great. Between these two computers, there's routers. Again, I just do a really basic diagram here. So router 1 has an interface on the 172.16 network, and it's got an IP of 172.16.10.1 and a MAC address of BBBB. Router 2 also has an interface on the 172.16.30 network, and its IP is 172.16.30.1, and its MAC address is EEEEE. And the link between them I just did the 5.5.5 network. It's a /24. So this guy's router interface is 5.5.1 with the MAC address of CCCC, and this interface on router 2 has an IP of 5.5.5.2 with a MAC of DDDD. All right, so the whole point of this is, let's say computer A is talking to computer B, right? They've already, don't worry about ARPs and all that. They're talking to each other, right? So when a packet leaves computer A, when we look at the layer 2 information, so when we look at the frame, so inside the layer 2, you're going to have a source MAC and a destination MAC. And inside layer 3, you're going to have a source IP and a destination IP. So the layers here are the OSI layers, 7 layers. If you don't know that, look that up. All right. So when I look at the source IP, what would that be? It would basically be coming from computer A. So it'll be 172.16.10.11. And the destination IP, well, let's say we're just doing a ping. We're pinging 172.16.30.11, right? So we're pinging that. So its destination is going to be 172.16.30.11. Great. Now what the layer 2 information looks like. So the layer 2 information is basically your segment, right? So the source MAC is going to be the computer A's MAC address. It'll be AA. And the destination MAC, and a lot of people will say, oh, destination MAC is going to be this guy over here. And that would be wrong. This is a layer 2 segment here. This is another different layer 2 segment, and this is another different layer 2 segment. So the destination in this example would be the default gateway's MAC address for the router 1, which would be BB. Okay? So computer A knows where its default gateway is. You set that up in its IP stuff, and then it would have to do an ARP to figure out. But again, we already talked about it. ARPs are already done, so it knows all that stuff. So this is what it would look like if I was sniffing the packet at this, or sorry, the frame at this point, or this point. This is what I should expect to see. Now, the router receives it, looks at the layer 2 stuff, says destination MAC is BB, that's me, gets the layer 2 stuff, throws it in the garbage, doesn't need it anymore. Takes the layer 3 stuff and says, oh, I need to go to 172.16.30 network, look at the routing table, whatever, all that wonderful stuff, says I need to send it to router 2, right? So at this point, this interface on router 1, let me go in here. Actually, no, I don't want to do that. Actually, let's change the color. Actually, this interface now on router 1, because that's where it's got to come out of, it's going to re-encapsulate the packet inside a layer 2 frame. So again, the source IP and the destination IP, a lot of people are going to say, oh, the source IP will be 5551 to 5552. That's wrong. The source IP is 172.16.10.11. Destination is 172.16.30.11. It's the same that left that computer A. So technically speaking, all along this whole path, that source and destination IP is going to stay the same. We have to know where it's coming from, and we got to know where it's going. 30.11. So I apologize for my horrible handwriting on my iPad. However, it's the layer 2 stuff that gets changed. So we're in the middle here. We're on this layer 2 segment. So the source MAC now is going to be CC, 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 and the destination MAC is going to be DD, 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 because this router 1 says, oh, my next hop for that route is basically give me router 2, which is this 5.5.5.2, and it knows its MAC address. Like I said, ARPs have been all resolved. Router 2 would receive it on that interface, look at the layer 2 information and says, oh, destination MAC is DD. That's me. Great. Tears it off, throws it in the garbage. Takes the layer 3 stuff, puts it back in and says, oh, you want to get to the 172.16.30 network? I'm connected to it. Oh, yeah, I know computer B. And then at that point, what we would see here, again, the source, the layer 3 stuff would be the same thing as here as is here, what it left. And it's the layer 2 that changes. So the source MAC would be EE, 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 and the destination MAC would be FF, FF, FF. Okay? So you need to know this, because if you don't know this, all the stuff that I'm going to be talking about won't make any sense to you, right? Also, if you're ever doing an NSX exam, they may ask you to know this type of stuff, to be honest with you. Now, when we talk about NSX, there's a thing called Geneve. We do encapsulation. Again, hopefully you know that if you're watching this. And that's where, you kind of need to know this stuff as well, okay? So So before we do that, let's do a packet capture, all right? Okay, so let's do a packet capture. So let's just go back a couple things here. And as I mentioned before, there's a couple of tools that we have. We have live traffic analysis. Let's take a look at that one. That's the easy one, okay? So let me get my screen over here. Let's go here. So first of all, a couple of things, and I've got this all recorded in the slides so you can watch it. I got Web 1 over here. Web 1 is on host 3. We can see it. It actually has an IP of 172.16.10.11. And it has a MAC address over here. Don't expect you to memorize that. But we'll see that it's MAC address 46.5A. Okay, we'll just leave that in the back of our minds. Then I've got, database. Oh, by the way, sorry. Web is also hooked up to a web segment. This is an NSX overlay network. Now, database is on host 1. So it's a different host. Database is on a different database segment. We can see here this is an NSX segment. Its IP address is 172.16.30.11. I got some pictures on that. And then, again, it looks like its MAC address is 4BC9, whatever. Okay? I'm going to go into Web 1, Web Console. Oh, I got two consoles open somewhere. Oh, here we go. And I'm going to initiate a ping to database 1. So I got a constant ping going from Web 1 to database 1. They're on different hosts. So that means you need to get involved here. So if I look at NSX now, if I go into plan and troubleshoot, under traffic analysis, you'll see trace flow. I've talked about that in other videos. Let's forget about that one for now. Live traffic analysis. Let's take a look at that. Let's click on getting started, right? So notice I don't have any sessions. Live traffic analysis allows you to do packet captures and trace flow. So let's say new session, and you'll give it a name. I'll call it whatever, my demo session. Call it something that makes sense. Now, this session, how long is it going to run before it stops? Like a timeout after. I've got 10 seconds here at default. Now, under trace and under packet capture is obvious. It's going to capture the packets and it gives you the option to save it to a PCAP file, and you can view it with Wireshark. So that's enabled, okay? Trace, what's that? When I talk about trace flow, if you want the ability to use trace flow for this capture, this is where you would enable it. Now, how many samples do you want? Notice it says between 1 to 50 over here. So maybe I'll just do whatever. How many do I want? I'll do 5. Actually, no, I'll do 2. And then over here, how many samples do you want for packet capture, right? And again, they don't have to be the same value. I'm going to say whatever. 3, just for argument's sake, but you see you can go all the way up here. So once it's captured 3 packets, that's when it will stop. If it doesn't capture those 3 packets within 10 seconds, it stops, it times out. Now over here it's got my source. It could be a virtual machine or an interface. So if I select VM, I get a list of my VMs here. If I select interface, again, it can be a virtual interface on a VM, an edge uplink, an edge centralized service, or an IPsec if you're playing with IPsec VPNs. I don't. If I select that, it's going to give me an error. I'm going to pick my edge. I'm going to pick a virtual machine. I'm going to pick Web 1 since we're starting from there. And if you got multiple adapters, you pick the appropriate adapter. Now I'm going to go add destination. Now, again, the destination could be a VM or interface just like before. I'm going to pick VM here, and I'm going to pick my database VM. I mean, that's the interface. Now, under advanced settings, this is going to capture everything. Maybe you're looking for something specific. So under advanced settings, I'm going to say, okay, I can specify, do I want just IP4, IP6, that sort of thing, right? Forward filters. I can enable these forward filters, which they are already on. So it's filtering for this IP, source ports. I can actually put in some more filters here if I want to, right? I'm going to, let me go into here and destination source port type, yeah. Oh, sorry, there we go. Got lost there for a second. Protocol type, I'm going to say I want ICMP. I don't want everything just to ping. That's the forward filters. The reverse filters, that would be the response back. Do I want to filter on that? Sure, I'm going to say protocol ICMP as well, just for this demo, okay? So again, this comes down to knowing your application, what's going on and stuff. To keep this simple, I'm just going to select ICMP. I'm going to go apply, and then I'm going to say start session. And then boom, notice it's in progress. And like I said, it's in progress, and it has that 10-second timeout. So if it doesn't see anything, it's going to time out. Now it should. I got a constant ping going there. I'm just refreshing. I'm hitting refresh. There we go. It's finished. Now watch this. I'm going to click on this session. And remember, because I selected, let me say new session here. Because I selected trace yes, let's cancel that. Because I selected that, when I click on here, come on, there we go. It's showing me in trace flow, okay? So it shows me the path it took. It went from web to the web segment, to a tier 1 gateway, to a database segment, and then back down to database. And you actually see it was on host 3, physical, hit a distributed firewall, hit a distributed firewall rule, it hit the web segment, hit the gateway, then the database segment, and then down to physical server 3. So notice over here. Sorry, folks. Let me pause that for a second. That was my little watchdog there. My neighbor has his excavator running, so I apologize for that. So where was I? So you'll actually see, now what's interesting here, if you look at this trace flow, you'll see it went, so it was on the ESXi3, that was where web is, web 1. Hit the firewall rule on web, great. Hit the distributed firewall rule, hit the web segment. Then it hit the gateway. And then it was forwarded by the gateway, so it came in one interface of the gateway, exited the gateway. Then it was on the database segment. Notice we're still on host 3, okay? So routing occurs on the source host. Then it's got to go from host 3 out to host whatever it is, host 1 or what, host. So it hits the physical. Now it's getting encapsulated. Then it's got to go to host 1, the physical. And you can actually see over here, it shows you on the right, there's my TEP IPs, my tunnel endpoint IPs. And then hits host 1, and then out to the database at that point. So over here, it's showing you the TEPs in this column here, these IPs and stuff. Okay, so this is kind of cool. That's the trace flow. If you're familiar with trace flow, there's nothing new there. Okay, but we're talking about packet captures here. Notice over here, download PCAP files. Great, I'm going to download this file. Now it's asking me, what direction do I want? Do I want it from database? Do I want it from the database going out, or do I want it from web? So you can pick your direction. I'm going to say from web, and I'm going to download that. Actually, I already have another one. Let me delete that. Let's save this one here. Yeah, I'll replace it, whatever. There we go. So let's minimize that. Let's get rid of that. Let's get rid of all this garbage here. There's my packet capture file. Okay. And I'm just going to double click on it. I've got Wireshark installed. If you're not familiar with it, it's open source. It's free to download, right? Now, when you look in here, you'll see the source. Now, this doesn't really, I don't want to say it doesn't really show you a whole lot, but it's not showing me any of my overlay. It's not showing me any of my Geneve traffic here. So if I look here, remember I said I wanted to capture 3, when I was setting up the session, I said I want to capture 3 packets. Right? When I was doing my packet capture, there's the 3 packets. So I've selected the first one, and then over here you can see packet comments. These comments is what? This says packet number 1, right? So let's pick the number 3 here. You'll see that changes. This packet comments was inserted by traffic analysis, by NSX, okay? You'll see the Ethernet, you'll see actually the source and destination IP. There's 46.5A. And then, so that's okay, so 46.5.8, let's take a look at that. What's that source back? That's the VMs. Come on. Let's go back to 46.5.8. I don't know if you can see it. It's right there. That's the VM Web 1's MAC address. Now, what's this other one here? Go back to Wireshark. So that's the source MAC, right? The destination MAC is 46. Destination MAC is right here. 025056564452. What the heck is that? Remember, let me show you here. I've got, let's go back into NSX. Oops, that's not NSX. I've got actually under networking, I got my web segment, and I got my database segment. So web VMs on the web, databases on database segment. They're going through a tier 1 gateway. So the interface on the tier 1 gateway acts what's called a VMAC. If you're familiar with that, it's a VMAC, and it's basically right here. This is the address. I always just remember 46, right here. 56, 56, 42, 44, 52, right there. Like, it's not letting me highlight it. 02, 50, 56, 56, 44, 52. That's the MAC address of the virtual distributed router. So it's leaving that VM Web 1, coming into the VDR to go out. Now, if I look at the layer 3 stuff, let's go into the layer 3 stuff. You see, it's right there. It shows you 172.16.10.11. It's the source IP. Destination is 172.16.30.11. That's the database. There's my layer 2. There's my layer 3, and it's ICMP. It's a ping. All right. Let's do this. Let's go. Let's go back into NSX, and let's go into Planet Troubleshoot. Let's go into traffic analysis. Sorry, folks. Let's go back into there. Let's click on my session. Now I'm going to download the PCAP file. I'll pick the other one, the database. Now I'm going to download it. Okay, so the database, I'll save that. Great, close it. Let's kill that. I got Wireshark still open. Let's kill it. And let's go to database now. So again, when I look at database, again, packet comments here, it's still the first packet. We see the source now is 30.11. And sorry, let's open it up. Let's look at the Ethernet stuff here. We see the source. We see the source IP is 4BC9. Let's go into vSphere. 4BC9, I said, right? Database. There it is right there. 4BC9. Okay. That's the MAC address of the database. And then we see the destination is, that looks familiar, 56, 56, 44, 52. That's the interface, the VMAC of the distributed router on the database segment. So yeah, it's the same. All right. Again, if you're not familiar with this, watch my routing video. Okay. I talk about routing. I talk about the VMAC and all that kind of stuff. So you definitely want to do that. I even do another packet walk in there too. So if you want some extra stuff in there, it's not a packet capture, but I walk through and explain that. So there's the layer 2 stuff. We see the IP. We got our source is 172.16.30.11. So it's coming back from database and it's going to destination 172.16.10.11. That's Web 1. So it's coming back from database, Web 1, and it's ICMP. It's a ping. Okay? So that's kind of neat. If that's kind of all the information you want to see, this little troubleshooting tool, traffic analysis, is actually kind of cool. All right? But suppose if you want to dig a little deeper, that's where we get into the command line stuff. All right? Let's take a look at the command line stuff. So let's take a look first at VM to VM on the same host. So in my lab environment, I've got host 3. I've got web 1. There's its IP address and MAC address, 172.16.10.11. It's the IP. Its MAC address is 46.5A, whatever. Then the app VM we're going to ping. The app VM is 172.16.20.11. It's on the app segment. And then we see the MAC address over here is 4055, and they go through the distributed router, right? Notice the distributed router, this interface right here has this IP address, 172.16.10.1. It's a default gateway for everybody on the web segment. There's its MAC address, that VMAC, 56.44.52. On the other side, the other interface of the distributed router, the virtual distributed router, again, notice it's on the app segment, where the app VM is. Its IP is 172.16.20.1, and its MAC address is 56.44.52. Same MAC address. Don't freak out. They're on different layer 2 segments. So that's okay, and it's only exposed to VMs. All right? So when we're doing this right now, what we're going to do is we're going to ping from web to app. That's what we're going to do. So when I look here, if I go back to my little pictures before, the source IP will be 172.16.10.11. Destination IP will be 172.20.11. End of story. Doesn't matter where it goes. Now, depending on where we're looking, if I'm looking over here on this part, the source IP and destination IP will always be the same on both sections. But the source MAC, on this left side would be 46.5A, and the destination MAC would be the VDR right here. When it passes through the VDR and it goes up to the VM, the source MAC will change to 564452. The destination MAC will be BA4055. Okay, so just keep that in the back of your mind. So we're going to capture, I'll show you capturing it again over here, let's say, and then we'll capture it over here as well. We could capture it here. I'll show you some of the commands to do this. Now, this is on the same host, so it has nothing to do with the TEP. The TEP doesn't get involved, all right? So let's clear all that. I know you don't know the numbers, but I know the numbers. You'll also see the web segment here. Okay, actually, yeah. So you'll see a web segment and an app segment. All right, so let's jump to it. Okay, so we're back at my machine here. Let's go into web. Let's kill that ping. Let's ping the app. 172.20. Come on, learn how to type, Steve. 172.16, 20.11. Okay, and just to show you, folks, excuse me, web 1 is on host 3. App 1 is on host 3 as well. Okay, so there's no encapsulation or any garbage like that. So let's go into host 3. Let's kill all this stuff here first of all. Let's kill all this. Sorry. Let's go into ESXi3. So there we go. So I'm just going to type in, first of all, I want to take a look at, if you want to take a look at some of the interfaces, there's a couple ways to do this, but one of them is ESX top. It's one of the ones that just popped into my mind, right? ESX top, I hit enter, comes back and shows me CPU utilization. If I hit end for network, it shows me network stuff. So you actually see over here, VM kernel 10 is on VMNIC 2. So there's my TEP, is on VMNIC 2. You see the VDR port, right? That's the virtual distributed router. It's your VDR. Think of it like a trunk port, okay? So that's one way to look at it. Where's my web? There's web and app. They're both on VMNIC. So web and app are actually using VMNIC 2. So that's the TEP. It's going out. My TEP is set up as active standby. Okay. If they're active, maybe web 1 might use VMNIC 2 and app might use VMNIC 3 to talk to the outside world. But we're not going to the outside world, right? Web's talking to app. It's on the same host. So I wanted to show you this is how you can find this stuff, right? Let me quit here. I'm going to type in NSX CLI, right? As soon as I type in NSX CLI, I'm now, you see the prompt changes, right? So I'm going to type in start capture, and it auto-completes, and I'm like, oh, I don't know what. I could hit tab again, and it comes back, and it gives me the commands, right? So I just typed in start capture, I hit tab, shows me what commands are available, right? I could do a trace if I want to capture this to use that trace flow tool. Okay, you could do that. I could pick my interface, or I could do DV filter. What's DV filter? Again, watch my firewall, distributed firewall videos, right? I can actually I could capture packets before it goes into the firewall and capture packets coming out of the firewall, a way for you to validate stuff. Maybe I'll do a video on that one, okay? So I just want to go interface. I'm going to type in interface. I'm not sure. I'm going to hit tab again, right? And that shows me a list of all the different interfaces. You see all these ports over here. You'll see app. There's web 1's interface. You'll see the VM kernel ports. You see the VDI. So it shows me this, which is kind of nice. So I'm just going to type in T1-web, and then, okay, I can't remember the rest of the stuff. So I'll type in, I'll hit tab, right? At this point, I can specify the direction or my count or expressions, right? A lot of this is in the documentation, and this can get you can go pretty crazy here, right? So if I just type capture that, if I hit enter, let's see what's going to happen. It's probably going to vomit back a whole bunch of stuff on the screen. You actually see the source, and then you see the destination. That's actually my app. Well, I'll just leave that going. That's my app VM. Now, suppose if I wanted to capture this to a file, right? So I could do this, and then hit tab, and then I could type in count. Let's say I only want 3 packets to capture. Let's hit enter on that and just see what happens. 1, 2, 3. Come on. There. And that's it. So we see here the layer 2 stuff. The source address is 46.5a, and the destination address is 56.44.52. So 46.5a is the MAC address of web 1, and it's going to it's going to the distributed router, right? So there's the VDR port, 56, 44, 50, 52. So it's going into the router. So I'm capturing it before it goes into the router. There's my layer 2. Here's the layer 3 stuff, 172.16.10.11. That's the web VM's IP, 172.16.20.11. That's apps. Beautiful. I can type in other commands, other ones here if I want to go count. I showed you the count, so it doesn't give you a whole bunch of stuff. You can type in file, and then you can actually save it. File whatever let's say myfile.pcap, and it saves it to a /temp folder. 3 packets will be okay, and if I go to cd space temp. Oh, I got to exit the NSX CLI. And you'll see my file pcap. So you can save it. I don't know if that's a good idea. You don't want to fill up the space on your host, right, guys? So just a food for thought. Let's type in NSX CLI again. Let's go back into there. And it didn't remember all that stuff. So start, capture, interface. Oops. I did a big typo over there. Start, capture, interface. Now, let's hit tab again. I captured it coming out of the web interface. How about the database the app interface? Let's take a look at that. Let's type in interface. This is tier 1-app, and I'll say count. Let's do a 3 count. Just give me 3 packets, and that's it. And we now see. So this is what's going into app. So we see the Actually, this is going into. Actually, one of the things I forgot to mention here. Let's do this. Notice it says direction is an option. So I'll type in direction, and then I get 3 choices: input, output, or dual, both. So let's say dual, and I'm going to do a count of 10. Let's see if that works. Count of 10. So this is app now. Okay, so what do we see? Good. We see some stuff changing here. So we see it's coming from the distributed router. That's the layer 2 going into app VM. That's the MAC address of app. And we see the source IP is 10.11, destination IP is app. Now remember, this is a ping. So it's pinging there. It's got a reply back. Look at the reply back. We got the reply back is source MAC is the app VM's MAC. Destination is the VDR, distributed router. Okay, because it's coming into distributed router. Here's the layer 3. 20.11 is the app VM. 10.11 is the web VM. So we see that's kind of flipping back and forth. All right. So this is kind of a cool, neat little tool. If you don't remember, like I don't have everything memorized, right? You could also do stuff like expressions. I think expressions have to be last. So if I do expressions, and these are like TCP dump expressions. If I hit tab again, it comes back and gives me a list of some packet capture expressions if I want to. Yeah. So I'm going to type in like IP 172.16.10.11, let's say. I'm filtering just for that IP address. Maybe that VM is talking a whole bunch of other. I just want stuff for that guy, right? So you can do filters like that. So your expressions are filters. Okay? And like I already showed you, you can capture it to a file. I did a count there. So that is basically the start capture command that we see from one VM to another on the same host. Kind of cool. Let's take a look at VMs on different hosts. Okay, so let's take a look at doing it on different hosts. So I'm going to ping. Let's go back into here. So let's go into web. And I'm going to ping database 30.11. Okay. So let's go back into here, and we'll see database is on host 1. Web 1 is on host 3. So so let's flip over here. So we're going to do encapsulation at this point, right? Let's go into right here. So let's do it on different hosts here. So what we see here, here's my web 1. It's on host 3. Here's my database VM. It's on host 1. Here's the TEPs. Okay? So what's going to happen here is traffic's going to flow down through the distributed router. Distributed router is going to do a route decision, and it's going to put it on the database segment. Now, hang on a second. It's got to get over here on the database. It doesn't do this. It's not a magic wire that goes across there. It doesn't do that. So it's going to come in like this, does a route decision. It's now on the database segment. Okay? Notice the VNI here. Okay? 71,680. Then it's got to come out, hit the TEP. It's going to get encapsulated. Let me change my color. It's going to get encapsulated by this TEP. There's the source IP of the TEP and the MAC address of the TEP. It's going to fire across here, and it's going to land at this TEP. You'll notice, again, the destination IP of that TEP and the MAC address. So remember, now we have a Geneve header, and we have our basic layer 2 frame as well, right? So we have a Geneve frame part and an encapsulated Ethernet frame. It will get decapsulated by this TEP, so the Geneve header will be all thrown in the garbage, and then the original layer 2 frame here will be sent up to the database. And we could capture at all points here, here, and here. We can capture everywhere. Okay? So let's take a look at that. So you'll notice my TEP IP is 172.20.11.153. That'll be the source. The destination here, since we're going from web to database, the destination here, the TEP on host 1 will be 172.20.11.152. You'll see the associated MAC addresses, which we'll take a look at. So we'll see here, again, we'll get 09C9 and then 350E. And we have the same, the distributed router now, its interface on the database segment is 172.16.30.1. Okay? So all that stuff should look the same. So let's, I've already started my ping, so let's jump right into it. Let's go into here. Let's go back into here. So let's start capture. I forget the command. Start capture. Oh, interface. Yeah, interface. Again, if I capture the web, let's do the interface T1-web count 2, whatever. It's going to the database now, right? So you'll see it's going from web to the distributed router. Source IP is the web one is the source. Shoot. And the target is database, okay? Beautiful. Now I want to capture it at that TEP. Okay, I want to see what's coming into the TEP. So let's do this. Interface. Now, so I want to start capture on my interface here. So let's go start capture, interface, tab, and it shows me my options here. Here is my TEP, VM kernel 10. That's my TEP there. Now my previous demo when I ran ESXi top, it was on VMNIC 2. So I want to capture VMNIC 2. So I'm going to type in VMNIC 2 because that's what my TEP is using. Again, use that ESX top, hit N, and I demoed that, okay? So now, if I hit enter on that, what's going to happen? Oh boy, I'm getting a lot of stuff going on here, right? So let's quit that. Let's stop that. So if I type in VMNIC 2, now what options do I have? Again, I can do a count. So let's do a count of maybe, I don't know, 10, just for argument's sake. Now I want to do a, I guess, direction. Actually, I don't even need the direction, to be honest with you. I'll leave that alone. Yeah, you know what? Direction. Direction. Come on, I can't type today. Sorry. Oh. think I got a, you know what, I should put the count before that, after that. Direction. Let's try that again, folks, sorry. There, direction, I'll say output, and then I'll do a count of 10. Now I want to filter some stuff here, right? So what I want to do is I want to see what's coming from my tap, right? Actually, let's quit this for a second. Let's quit this. I want to see what's coming from my tap. So if I just type in, let's exit. I want to see what my tap IP is. One of the commands are ESX-CFG-VMKNIC-list. Did I exit out? Yeah, I did. Oh, okay. ESX-CFG-VMKNIC-list. There we go. So if I look here, this is all kind of crunched up. But you'll see VMK10 is right there. All right. There's its IP address, 172.153. Okay. And then here's its MAC. Sorry. Here's its MAC right over here on the far end here, 09C9. So it's 153, 172.20.11.153. So let's go back into the NSX CLI. Again, all this stuff you should write down when you get in there. So let's do start, capture, interface, VM NIC2, direction, output, and then we'll say expression IP 172.20.11.153, expression saying filter for that IP address. Oh, did I put a count? I don't know if the count's going to be valid here. I'll say count 10. You going to like that? It doesn't like that. I'm going to put it before the expression. Yeah, it's got to be, the expression's always last. It's going to be count 10, expression, whatever. So we give it a few seconds here. So it's actually coming back now. Hopefully it doesn't fill up. Maybe I should have did count 5. Oh, no, there we go. So one of the couple of things I looked for, what I'm looking at now is there's Geneve header information in here, and there's encapsulated stuff. Now, one of the things I see here, this is a tunnel endpoint bridge. I see VNI0. What the heck is VNI0? I remember first seeing that, right? VNI0, if I actually come through here, I look for here. Here's VNI. There's 11.800, which is, sorry, I'm just looking at my sheet here. 11.800 is my database segment. So there's a encapsulation here, 09C9, and then it's going to 35 OE, right? So that's my taps. There's my source and destination TAP MAC addresses. There's my source IP, 172.20.11.153, so that's host 3. And then 172.20.11.152 is host 1, okay? So this would be the source MAC of host 3, the TAP, and a destination MAC of host 2. You see I have my Geneve. You see the VNI. That's the hex value of my database segment. Let me just to show you something here. Get logical switches. My database segment is 71,680, and that's what that hex value represents. Okay. Then now, so that's the Geneve header, pretty much around there. That's the Geneve header. Then after this is what's been encapsulated inside it. I see 564452. That sounds familiar. That's the VDR. I see 40C9. All right. And then I see the source IP. That's 172.16.10.11. So that's the source MAC. Sorry. And then and the destination is 30.11. So this is basically when it came in. Let me go back to my iPad here. So if I clean this up, what I was looking at is what was there. So the source MAC would be this. Destination MAC is this, which we see. And the source IP, again, that stays the same, and the destination IP stays the same. But all that got sent across here, decapsulated, and fired up, and none of it changed. So this VM's totally unaware of that going on. So that's kind of cool. So this is showing me that. I think that's about it. I'm not going to demo the pcap-uw command. Very similar type of thing. I kind of like this one. It's actually simple, to be honest with you. Again, you don't have to be a master at it. You can tab around and kind of figure things out. It's not so bad. But anyways, I hope... Sorry, I want to make sure I was recording. I hope you enjoyed this video. If you liked it, hit that thumbs up. If you found this beneficial, please hit that subscribe button. It helps me out a lot. Without subscribers, there's no content developers, right? And I'm pushing to get 1,000 subscribers or more, okay, folks? I'm really pushing for that, right? So I appreciate for those of you that have subscribed. This was actually a request from one of my subscribers, so I hope you found this beneficial. Leave your comments below. If there's something you want to see or have me cover, please leave a comment. I will do my best. I have limited resources. I'll do my best to see what I can. And I always comment. I always reply back to all my comments, okay? So thanks very much. Have a great day. See you in the next one. Bye now.